Hello, everyone. Welcome to QCon. I'm very excited to keynote today. My name is Felienne Hermans, and I'm going to talk about my book called The Programmer's Brain today. Specifically, we'll zoom in on the topic of how to read code. I'm on Twitter as well. My Twitter handle is @Felienne. Very easy if you know how to spell my first name. So if you are tweeting about this, do mention me so I can see what people are tweeting. It's a bit hard to get a sense of the room, of course, in a remote way. So I hope through Twitter I can still get a sense of what people think of the talk. So before we really dive into reading code and the programmer's brain, I want to take you through my personal history of how I came to study the programmer's brain and how I came to study code reading. So we have to go back to the year 2013, in which I started to teach kids programming. 10, 11, 12-year-olds at a community center in my neighborhood wanted to learn programming. So I was like, sure, kids, I can teach you programming. I was like, how hard can it be, right? They're children. Even though I didn't know that much about teaching, I figured it was not going to be hard. And what happened then is subconsciously, I started to think back at how I learned programming when I was a kid. So this is me programming when I was about 10 years old behind a big computer. I was really small then, but also computers were really big in the 90s. And when I was learning to program, I wasn't really going through a programming lesson or a programming tutor. There were no programming lessons. There were no adults around that really knew programming. So I never really took a programming lesson. I learned programming from a book. And maybe some of you of my age have the same experience that these books weren't really explanatory books. They just had printed out source code in them. So this is how I learned programming, by reading and figuring stuff out, and ultimately, of course, getting a sense of what those codes mean. And it isn't just me. As I said, many people my age share the same experience of learning programming without a teacher, without going to a programming lesson. Like as a field, we sort of miss a collective history of what a programming lesson looks like. And you might wonder, why is it relevant for code reading? Well, the fact that we don't really know how to read codes directly relates to the fact that we never took lessons. And I'll show you in a bit why that is so related. Because we never really went through a programming lesson as a community, we don't really know how to shape a lesson. I certainly didn't know how to shape a lesson. So I just let the kids explore. And this is something still very, very visible in our self-image as a community. Just let people explore. Just let kids explore on their own. They will figure it out. You still see this vibe very much in programming for kids books that you can buy now, so not in the 90s. But today, if you look at programming books, you see that those are written by people with the same experience. For example, here's a book, Computer Coding for Kids. The snippet is in Dutch, but there's an English translation underneath. This says, never be afraid to mess around and experiment. This is very much the perspective of someone who doesn't have a teacher close, right? Because if you have a teacher close, maybe messing around and experimenting isn't necessarily the most effective way to figure stuff out. It might be more effective to ask your teacher in a more guided setting where that would be valued. Maybe books should say, never be afraid to ask your teacher if you're stuck. Saying something like, never be afraid to mess around and experiment, it's very much the best if you don't have a teacher. Maybe it's not the best if you do have a teacher. And this is still very, very much tangible in our community today. This just let kids explore. This is what I did in my programming course also with the kids, and it wasn't really working all that well. Kids got really frustrated when I let them struggle and explore and figure stuff out. So then after a while, I also got somewhat demotivated. I was like, why don't they learn anything from figuring stuff out? I learned stuff from figuring stuff out. Why isn't this working for everyone? Why isn't it working for the kids in my class? Because like these were kids that came to the community center voluntarily on their day off, on their free Saturday. So it wasn't like they were motivated or anything. Clearly, like I was doing something wrong. So at that point, I got very, very motivated to understand how people learn. And I started to read a lot specifically about how people learn their first natural language, or English, or Dutch, or German, or Japanese. there's lots and lots of research about how kids acquire their first natural language. And I thought maybe there's something there that can help me gain an understanding of why the kids in my class are struggling so badly. So from that, I got this idea that, we never really teach reading code. And that might again have something to do with the fact that we used to not have teachers. We never really teach reading code specifically. So going back to how stuff worked in my programming class, is kids would say, "Hey teacher, I made this code like last week, and I don't really remember what it does. So can you help me figure out what this does?" And then I would be like, "What do you think it does?" Right? Because in my mind, I had this never be afraid to mess around and experiment idea. And this, of course, this situation isn't limited to teaching kids. Even in onboarding people in my open source repository nowadays, I still sometimes feel that I am reluctant to give answers. If someone says, "Hey, where in the code is this located?" I could just say, "Well, it's there." But it is fun. It is nice to see this sparkle, to see the light go on. So people would rather sometimes give hints rather than just give an answer. And partly this is probably because this community was shaped so much by self-teaching that we think that if you figure something out, you'll remember it more strongly. So the kids, of course, in my class, they were kind of frustrated. It's like, "Well, teacher, I came to ask you. I don't know. So it's not really helpful to ask me what I think because I have no clue. I have no conception." So we don't really teach the act of reading code. We don't offer strategies to novices. This is how you read code. I've seen third year students in a computer science program, if they needed to interact with some code and I said them, what this do, they would like take their finger and go to the first line and read it from top to bottom. And first you're like, "Wow, why are you doing that?" But then you're like, "Well, I never explained to you anything else. So yeah, surely you fall back to the strategy that works for language." Secondly, and now we're moving more and more towards professional practice. We also don't practice reading. Like we professional software developers, I should say, spend lots of time working with code, reading code. And there's an estimate that a professional developer spends as much as 58% of their time reading code. That's more than half of your time is spent on reading code. However, as a culture, as a community, we still very much emphasize that you will get better by writing more, right? Oh, if you want to get better at programming, you should have this Saturday open source project, or you should just learn a new language and make whatever you want, like make some, I don't know, calendar app or something. And this is again rooted in this never be afraid to mess around and experiment vibe. We want to mess with the code. The code is truth, right? You see this also in the type of things we do as a community to advance. It is getting later in the year, it is almost December. So people start thinking about Advent of Code, which is this thing where in December, every day you do this little programming puzzle, which is lovely. But again, it is production. So if we celebrate our skill, getting better at our skill, then it's almost always focused on practicing writing, code writing, and hardly ever focused on practicing reading. So we don't practice reading. The third thing that I figured out from really diving into natural language learning is like we don't really know what happens in your brain when reading codes. We know a bit. There's some scientists, really cool work from a German scientist called Janet Zygmunt. She takes programmers and she puts them into an fMRI scanner and measures what happens in their brain, which is like super cool. But by and large, we're still figuring out what happens in your brain if you read code. Luckily, we do know, as a society, we do know much about what happens in your brain when you read language, what happens in your brain when you process information. So in the rest of my talk, I want to take you through what actually happens in your brain when you process code and information in specific, and code in specific, I mean. And then we'll see what that actually means for your daily practice of programming. So if information comes into your brain, through your eyes or through your ears, it firstly enters the short-term memory, where it's stored for a very, very brief time. This is like a little bit like an I/O buffer, very small and stored very briefly. We've known this for a very long time, actually. George Miller, a researcher already in the 1950s, described that your short-term memory is very, very limited. very small, and it might only be able to hold between 5 and 9 things at the same time. So it's a very brief storage. It is not something you can just clamp lots of information into. And just to give you a sense, because I know just saying like 5 to 9 elements is very, very abstract. So let's do a little experiment. I will show you a very brief sentence for a very short amount of time, like half a second. And then it's your goal to remember this sentence. I hope you're participating at home. Here we go. So that was really hard, right? Now you're like, well, this is impossible. I cannot process that information. So this is the limitation of your short-term memory. You look at this information, and even if I would have allowed you to study it a little bit longer, you would not have been able to really remember all the characters because your short-term memory is so small. But I guess you also figured out that I only showed you part of the puzzle because, well, these weren't real letters, right? Right. It isn't just your short-term memory that does the processing. Your short-term memory takes information that comes into your brain and sends it to the working memory. And your working memory, you can see that a little bit like a processor in the brain. It is processing information. Your working memory works together, collaborates with the long-term memory. So your long-term memory is it's a bit like an angel on your shoulder that when presented with information, when information is in a working memory, your long-term memory will be like, oh, I know this information. Here's related information that also might be of value to you. So it's always trying to give you information that you already know to help you process the information currently being processed. To see this process in action, we will do another puzzle. Similar puzzle, 3 words shown very briefly, and it is your goal to remember the sentence. Here we go. So that was easy, right? It was still hard, but I guess it was easier. And I guess also your little long-term memory angel was jumping on your shoulder, I hope. It was going like, oh, ABC. Oh, that's not a C, that's a K. MBR. And then probably this is when the sentence was removed. But something was happening, right? You were recognizing letters and you were trying to make sentences out of the letters or words and then sentences. This is because your long-term memory was now activated because recognizable stuff was shown. To show the power of the long-term memory for processing, we will do one more memory exercise. Very similar, 3 words shown briefly. Here we go. Don't blink or you might miss it. So that was doable, right? That was probably relatively easy. So you see, the more you know, the more you can process. These cat lost cake, for you, it's relatively easy. You just look at the words and immediately you grasp it. The trick here is that your brain isn't reading CATLOV. It's certainly not doing half a circle, oh, and a circle and a squiggly and a Catholic cross and a stripe. Immediately, you see the letters, you see the word, and you think of the concept. This is what makes it so easy for you to process this information. And I think already here there is a takeaway. Because if you are working with someone less experienced in your code base, less experienced in the programming language that you're using, you might show something to them. You might show them, oh, look, it is a cat. It loves cake, right? Something in the code that you know very well. But for the novice programmers, it might just be letters. It might just be characters. Because if they don't know enough about the code base, about where stuff is and what is the meaning of keywords, what is the meaning of domain concepts, then it's not like they don't remember. It's that it doesn't even enter their working memory properly because they can't process. So what you know very much influences what you can process. So these chunks, is what is called individual elements, are retrieved from your long-term memory. It isn't like this language, English, is inherently easier than the made-up characters I showed you earlier. It's just that you know more. So let's take this back, this knowledge that we now have about cognitive science, towards programming. Let's look at 3 different programs and the memory systems that they involve. Here's a program written in APL, a programming language. And if I ask you to read this code, just like you can think about it for a second, what this does. You can process the twos. I guess you can also process the n, and you sort of know that that is a number, maybe an integer even. But I'm going to guess that most of you are stuck there, stuck on the t, because what is this? What does this t do? This is just a long-term memory issue, right? You just don't know what it does. It isn't that it's hard to remember this code. It's not hard to process. It's just you lack information. Here is code that is confusing for a different reason. This code is written in Python and in a sort of a Pythonic way. If you're not familiar with Python, this is called a list comprehension. And this creates a list. I guess you can see that from the rectangular brackets. It creates a list based on an existing list with a filter. If you know Python, this is very easy. This is cat loves cake for you. But there are many elements here. So if you're not so used to Python or to this specific language construct, and it is customer names c dot first name for c in customers, this is more than the 9 elements that your brain can easily process. So this is a short-term memory issue, potentially, depending on your prior knowledge. Here is code of yet another confusing type. Here, I'm going to guess most of you are familiar with the concepts here, even though they might not know basic. Most of you know what a let is. It's an assignment and a for and a return and a print and some assignments with some mathematical calculation. So like long-term memory is like, okay, I got it. I know these things. And there's much information, so your short-term memory might be overloaded, but it's not only that, it's also that you go like, okay, I see the individual parts, but like how do they work together? It's almost like you would want to take your finger and go like, oh, well, uh, I don't know. Let's put n is 7. Okay, if n is 7, then n divided by 2, this is 3, this is string 1, right? You cannot at once grasp the program. You have to do this step by step. Basically, your mind wants to play the compiler to figure out what's going on. This is a working memory issue. You have all the information, you understand all the information, but you're not able to put it together. So these different forms of confusion are important because if you recognize what part of your brain is engaged too much, is struggling with a certain piece of code, you also know how to solve it because each of these different forms of confusion have a different solution. And if you just pile them together as, oh, code reading is hard, this is confusing, I don't know what to do, then you don't know what to do. Whereas if you understand, oh, this code is hard because this presents a long-term memory issue, you also have a path towards being less confused. So for this type of code, where we have a long-term memory issue, the path to less confusion is to practice syntax. And a nice strategy for that is flashcards, in which you make little paper cards, a little bit like this, like business cards, and then on one side you put the syntax element, and on the other side you put the definition. So if you are learning APL, you could say, well, this is a T. It's actually not a T. It is an encode symbol, and you can practice. But of course, assuming most of you don't want to learn APL, what you can also do is put Python on one side and Java on the other, and then train yourself in that. Or if you're not necessarily struggling with a new programming language, but with a new business domain, you can also put domain concepts on one side and the definition of the domain concepts on the other side. And you simply put this stack on your desk, and every once in a while, you take a card and you're like, do I know this domain concept? Let's see. I do know this, or you don't. And then you practice again. And the book has a lot more strategies to practice, but this is just something you can do to practice. So it's really important that if your long-term memory is suffering from confusion, it doesn't make sense to plow on. It doesn't make sense if you're reading codes in which half of the main concepts are unfamiliar to you to think, I will just read this again. It will not get better. You really need this familiarity. It shouldn't cost you too much energy to process individual parts of the code. Otherwise, you will not continue. And again, think of how much easier it was to process cat loves cake than the other 2 sentences. Don't let yourself be in such a situation. This code, though, has a spectacularly different type of solution. If you're struggling with code that is of which you know the individual elements, but they are shaped in a form that isn't so convenient to you, what you can do is rewrite the code. So if you are maybe coming from Java and you're not so used to list comprehension, you can rewrite this code. This second code snippet does the exact same thing as the top code, but might be, depending on your prior knowledge, way more comfortable to you, where you say, oh, I make an empty list, and then what I do is I loop over this list customers. For every C, I check, are they older than 50? Yes, then I add their names to the list. And this is what I call in the book a cognitive refactoring. It is a refactoring because you're not really changing the behavior of the code. It is the same code snippet, but you're taking the code and you're moving it closer to your own prior knowledge. If you're not so familiar with list comprehension, the second form is easier to use. And of course, like this snippet isn't the code base, right? You must imagine that you're in a big method of which some list comprehensions are part. And that is just a waste of your time if for every list comprehension you go like, oh yeah, oh, what is this again? That distracts you again from the bigger picture. So you can rewrite parts of the code to make it easier to process. Again, the book has a lot more different cognitive refactorings. There are all sorts of other things you can do to massage the code to be more easily processable for you. Some people now might be yelling angrily right at their screen saying, this is not a refactoring, you're making the code worse. So in some cases, it is true that you would want to roll back this code to its original form. But if you have something like a GitHub repo, of course, you can just make your own branch, do some refactoring there for comprehension, and throw away the branch later. So in many cases, this is not a refactoring you want to commit. It's really refactoring you use temporarily to gain a better understanding of code. Finally, then, if you have code that is of this type, where it's just really hard on the working memory, you can support your working memory. You can use techniques, many of them are described in the book, that help your working memory. Where you're like, oh, I am processing too much data at once. Let me offload some of this data onto a piece of paper or a whiteboard or even in your code. For example, just an example is to make a little state table in which you say, okay, I'm going to try to understand this code for the value 7. Just say, okay, this is the initialization phase. Okay, now this happens in the first loop, this happens in the second loop, and that can give you a better grasp of what the code is actually doing. So, in summary, in short, if you understand your own understanding and understand your own misunderstanding, this will really make you a better programmer, because instead of just saying, I am confused, you can say, my long-term memory has too little prior knowledge. I need to improve that. So it will help you, hopefully, out of a situation in which you feel confused and powerless, and gives you techniques to help you out and to help you advance to more understanding. If you want to know more, there's many things you can do. One thing you can do is read my book. I will have a link at the end of this talk so you can buy it and read it straight away. In this talk, we've covered like chapter 1 and a little bit of 2 and 3 and 4. And there are 13 chapters, so there's much more to learn about the impact of naming on your cognition and the relation between code smells and the working memory and the short-term memory. A lot more to explore, but all aimed at understanding your own understanding in the context of being a programmer. Something else you can do, which is also very fun, is starting a code reading club. This is an idea that I coined in the book and that I've been exploring for a while, where people get together and they just read some code together, like something from their own repo or something random from GitHub. We have all sorts of little exercises that you can do in the book, but also on a free website with resources that I will also link to at the end of the talk, where we have code snippets that you can use for reading and exercises to use in a code reading club. So if you want to explore that, that's definitely possible with free resources. That's it. That's everything I wanted to share with you. Again, I'm on Twitter. I'm at Felienne, and you can go to my website, felienne.com, for more information. For example, felienne.com/book is where you can buy my book and explore all the things we talked about in the talk. You can also go to felienne.com/club for a link to the free code reading club resources that I've put together with other people as well, all named on the website, that have helped me shape code reading clubs. One question you might have before we go to the official Q&A is like, what about the kids? So you started to teach kids and you were failing, and then you wrote a book about programming and cognition. That's true, but then there was this other part of the puzzle for me as well. In addition to everything I learned going into a book, I also put everything I learned about how to learn into a new programming language for children called Hedy that really takes into account what we know about how kids learn and tries to use that knowledge to make learning programming for kids better. You can go to felienne.com/Hedy to check out Hedy, which is free and open source and available in 17 different languages. So wherever you are, it's a big likelihood that you can do programming in Hedy in your own language, which is, of course, a lot easier for kids. If you like listening to me and you want to listen to me for many, many more hours for free while you commute to work or do the dishes, that is possible because I'm one of the hosts of SE Radio, Software Engineering Radio, an interview based podcast that occurs weekly where we interview people from all parts of the software engineering domain. So, from programming languages to databases, but also soft skills like how to interview or how to write documentation. All of that and more available also for free on iTunes and Spotify. And with that, I think it's time to go to the Q&A. See you in a bit.
Yay! Nice job. Awesome. So I love the short-term working and long-term memory. It really, I don't know, it just appeals to the engineer soul in me, helps me kind of map and reduce problems, I guess. Was that work based on George Miller, or was it just the initial thought of short-term memory and then you shaped the rest? Where did it come from?
Yeah, so it's a combination of different things. So I really immersed myself in cognitive science there for a while. Yeah. So definitely George Miller's work is underlying, and there's also work by a Dutch chess player and also cognitive scientist, Adriaan de Groot, who really researched how chess players learn chess, and specifically how really expert chess players think. And he also describes that really good chess players are really good at pattern matching. And initially they thought that maybe it's just because they have superior brains, but then it turned out they had just seen so many chess games that they were really good at saying, oh, this is a Sicilian opening, or this is this, or sometimes even their own personal memory, like, oh, this game is like the one I played with Betsy on that rainy Saturday afternoon. So they just had this really big repository of patterns to use in playing. So Adriaan de Groot's work was also very influential in my thinking.
Patterns was the word. As you're describing it, they have design patterns for chess that they're able to apply and say, oh, this is, I don't know, a chess pattern, so I should, but here's a pattern to actually implement.
Yeah, I actually talk about that in the book as well, how our design patterns actually work that way, that because you know a certain design pattern, that we as expert programmers, we look at code and we don't go line by line. We just say, oh, this is the decorator pattern applied to that variable. So then with the design pattern, it becomes get lost cake, right? Whereas for a novice, a junior programmer, there's not something like warning decorator pattern, right? Maybe it's there, but maybe it's not. But we can still see it from structure, even though nothing is saying decorator. And then sometimes the junior's like, whoa, where did you get that? It's like, well, 2 decades of experience.
You see a singleton, you immediately know the pattern. Yeah, absolutely.
Exactly.
Right. So everybody, I have a few set of pre-questions. We're just going to kind of warm the cache, so to speak. I'm watching the chat, so please ask questions. We have about 13 or 14 more minutes here to have a discussion with Felienne. I'm going to keep going, but ask your questions away.
Yeah, I've tried to keep up with the chat a bit in the talk, but I'm now lagging behind. So it's good if you can make a selection there.
So one of the questions that I have is, in the short-term, working and long-term memory, as you move throughout your career, do you always move through those stages? Do you just spend less time in each stage when you build up kind of that pre-knowledge of like ifs and loops and kind of the structures? What does that look like?
Yeah, so in principle, yes. So if you learn a new programming language now after having lots of experience, then yes, it becomes easier because you can do pattern matching quicker. And the closer your language, of course, is to languages you already know, the easier it is. Like if you go from C# to Java, that's like nothing almost. So you'll be able to very quickly have these concepts. I have a whole chapter about learning second languages actually in the book. There's this principle called transfer, which is exactly using knowledge that you already have in a new context. You have positive transfer, and if something's really close like Java or C#, then you have lots of positive transfer and maybe just a little bit of negative transfer with like checked exceptions that are a bit different. But if you are going from Haskell to JavaScript or from PHP to C++, then you're going to have both positive and negative transfer. So then it's not only going to be, your experience is not only going to be helpful, it's also going to be detrimental. Because, for example, if you go from Haskell to another language, then suddenly you have to deal with variable assignments and stuff is mutating all over the place. And you have no mental model for that if Haskell is the only programming language that you know. So then it is not helping, it's actually making you less productive. And we sometimes see this with students, that students with prior knowledge in a language that we don't teach actually do not have a good time because they have to unlearn so many things. Absolutely. And they see themselves as experts.
I actually was going to ask about that, and I think Jesse asked a question related to it too. How do you unlearn things? Like Jesse's question is, I wonder how this applies to like Java 8 Streams API. He's more comfortable with, and I can relate, the nested loops and conditionals than jumping straight into the Streams API. So he has this like pre-built knowledge on how to solve this programming problem, and this new approach, you almost have to unlearn the other approach to be able to really kind of grok the new approach. How do you deal with that? What's the science behind that?
Yeah, we have a lot to work on that in the book as well. So sadly, like unlearning things is not a thing. Once you know something, you know it. And you can't really forget knowledge. This is very hard, especially if you've used this knowledge very often, then it will continue to come back to you. Yeah. I have not programmed C# in over a decade. Yet sometimes if I'm very engaged in programming and I'm looping over list elements, I will type for each in Python. And I'm like, don't do this, and it keeps happening. So unlearning sadly is not a thing, but what you can do is deliberately teach yourself or practice new knowledge. And there's this idea in the book that I described that's called conceptual change, in which a concept for you changes into something slightly different. And if you learn multiple programming languages, then the concept will morph into something generic, where you're like looping, instead of just knowing a loop in C, as you maybe learned when you were an undergrad, now you know this concept of looping at a more abstract level. So you can try to train yourself to see these concepts in a more abstract way, but learning new things is hard, but learning slightly different new things is maybe even harder.
Yeah. So I'm curious, you use that flashcard example. That's like one of my favorite ways to prep for like a cert test. But one of the challenges I have is that if I'm not like actively using the construct that I'm working with, then it leaves my memory. So why is it? Is it long-term? Is it working? Where does it sit that I can't seem to keep it?
Yeah, so there's so much more stuff we need to talk about. So you have the idea of retrieval strength. And This is in your brain, not necessarily how well it is stored, but how easy you can find it. Like in computer terms, like how many pointers do you have to this specific piece of memory? Yeah. So if you retrieve something from your memory, your human memory, then you strengthen this connection. So the more often you remember something, the easier it is to find it. So it will still
move it to RAM. Okay, I get it.
So then it is like cached. It is easier to access.
Move to cache.
So if you haven't accessed something in a very long time, then you forget it. Like I now have like this RFID thing in my phone, so I can pay with my phone. Now a while ago I had to use my old-fashioned card because the shop didn't have the phone thing, and I was like, shit, what's my code for my card? I don't remember because I haven't used it in such a long time, and like I must know this. I know it, and of course I knew it after a while. But that exactly is retrieval strength, that if you don't retrieve something often enough, your brain is a super efficient machine. Your brain is like, oh, you don't use this code for your card? I will put this somewhere in the back.
Yeah, that's right. Write it to disk.
Seems like you're not using this.
Very cool. So I'm curious about some other techniques, and I guess to help teams kind of just work on this the strength. So things like unit tests and code reviews. What are your thoughts on tools like that and how they help teams just kind of level up?
Yes, that's a great question. So I'm going to go back a little bit to those code reading clubs because I found that
Yeah.
that is such a good way as a team to communicate it. Like they've been working in ways I didn't anticipate. So if you read code as a team together, then not only are you practicing your code reading skills, you're also sort of leveling your understanding. So someone will say, "Oh, this code is really hard for me because it uses list comprehensions, or it uses this type of map reduce stuff or immutability that I'm not really used to." So people get aware of like the things you do, the things you know. And it's also a really nice way to discuss design decisions without being in the situation where you're making design decisions, right? In a code review, you're never neutral. I have made code and someone says, "Well, I don't like it that you mutate state so much." This isn't neutrally saying, "Hey, how much mutation do we allow in this code base?" This is, "You are doing it wrong," right? So it's really nice to split these discussions of this specific part of code or what in general do we want. So these type of discussions about code also very much then ease code review, because you then have this shared idea of where you want to go with the code, not in terms of features, but in terms of design.
Yeah, totally. So one of the things that I found that really works for me, and I call it deep thinking. I don't know if that's the right phrase, but that's what I call it. I saw Roland Martins asking a question in here. So one of the things he's always done is every December, he kind of prods me towards Advent to Code to kind of make sure that I'm getting into it. Thanks, Roland. But last year or the year before, I think it was, Python was what I focused on, what I dug into, because ML, AI, all those kind of things. But what I found really useful was being able to struggle with a problem and then get an implementation and then go back and read other people's implementation. So code reading, that's how I applied it. Why does that in particular really works for me, to be able to, I don't know, I think deeply about a problem and then read code? Why is that?
It's because you're an expert. It's just because you're really good. And so there's this really interesting concept called the expertise reversal effect. So if you're a novice, then plowing on isn't useful. But once you're an expert, it's actually fine, because you're not going to be discouraged by all this
I
confusing
see.
stuff. So at a certain level, different things work than at the lower level, which is also this it's very hard, because what works for me, you tend to think what works for me will also work for little new junior just out of college, and that
Right.
is not true. So if you experience this, yes, it's because
Makes sense.
you're learning your fifth programming language, and also very likely you will have solved similar problems before. So you're using
Yeah,
a combination of your working memory but also
that
your
makes sense.
long-term memory. You will be thinking, "Oh, I solved this before, like 5 years ago at this customer,
Yeah,
maybe in a different language." But you have a repository of strategies and syntactic elements and concepts that you have in your long-term memory. If someone
yeah.
lacks that, then it's going to be all working memory for them. And that's where the difference is. That's just because
So
experts learn differently than beginners do.
that's a huge important concept for me. I mean, to understand right now, because like I've worked with so many different languages, and I just kind of expect new people to do the same and just constantly go relearn something. If you're not relearning a new language or a new thing, you're antiquated. Your legacy code in software. So I get that. It's nice to have that. I guess mental form to be able to make sure that you recognize that. That's awesome. What other, so speaking of that, speaking of senior people and junior people, what things do you recommend? Like we talked about, code reading, we talked about unit tests. What do you recommend for senior people, whether that's leadership or just developers, on helping more junior people kind of get to where they're experts at code?
Yes. So some of the things we talked about in the book already, in the talk already, that you can do to yourself, you can also do that for someone else. Like a cognitive refactoring in itself already takes some energy. So this is something you can definitely do for a junior. You can take the code and you can say, "Well, I massage it a little bit, so I put it in a form that will work for you."
Yeah.
Or do something, we also described that in the book, that's called scaffolding, where you put some stuff there. I sometimes do this even with contributors in my open source projects, where I'm like, "Okay, I'll make a branch and here's some gaps for you to fill." And that's useful because it lowers their cognitive load. but also it ensures that the architecture is sort of in the way that I want it to go. So that's definitely something you can do. Instead of saying you add this feature, say, hey, I already added it to the front end, so the button is there and the drop down is there, and here's a function, and you just implement this function. You don't have to do this switching between front end and back end. You just implement this thing, right? Or the other way around. I already made the logic, and you just is hard for a novice. You just have to add it to the front end. So dividing a problem in sub-problems and then adding, we describe this in the book as well, as sub-goal labels, like this part of the code will do this. This is the goal of this thing. This is the goal of this thing. And then someone else just fills in those gaps.
Yeah, absolutely. I'm just scanning through the questions here to see if there's any I can load really quickly. They're long questions. They're hard to load really fast. So, so I'm trying to load them. Let's see. So I see one question about, what language is really good for first-year students. Obviously, Hetty. You want to talk about Hetty and why you feel that's a great language for first-time students?
Yeah, for sure. Yeah, so what we do with Hetty is we split concepts and syntax. So instead of saying, hey, this is a for loop, and you type it like for I in range, that's super complex. So we do it stepwise. First, we say, hey, this is repetition. And then the syntax is super easy. The syntax is just repeat 3 times, and then you can repeat something. So we first do the concept, and then once the concept has landed, we add a little bit of syntax. So this is exactly aligned with what I talk about in my book, that we try to, and in the talk as well, that we try to like ramp up slowly and don't overload the working memory that has to then think about syntax and concepts. We split this, and it's free and open source.
Yeah, very nice, very nice. Well, be sure to go check that out. Definitely check out the code reading. And Felienne, thank you so much for the talk. I really, really like the short working term and long-term memory, because it helps me kind of think about where my problem is. So thank you so much for that.
Thanks so much. If you still have questions, I'm available on Twitter, so feel free to hit me up with questions on Twitter.
All right. Thank you all.
Bye-bye.